Please welcome to the stage Director of Public Sector Marketing for Amazon Web Services, Tricia Davis-Muffet.
Hello, everyone. Welcome to our very first Public Sector Summit here in Singapore. Thank you so much for being here today. So we have a great day planned for you. First up, we'll have a very exciting keynote where you will hear from innovators who are helping to change the world and innovate, break down barriers, both AWS executives as well as our customers. So I hope that you will enjoy that. And then afterwards, you can choose between a management or business track and a technical track. So depending on what you're interested in, we have something that's right for everyone. I do want to take a moment to thank our sponsors. Without them, this would not be possible. So thank you very much to our platinum sponsor, Intel, and also to our gold sponsor, AsiaPac and Hitachi, and the silver sponsors, Trend Micro and Workplace by Facebook, as well as all of our bronze sponsors. I do hope that you got a chance to talk to them in the expo area across the hall this morning, and I hope that you will spend time with them during the breaks and throughout the day. They have a lot of really interesting solutions, and they're there to help you move things forward faster. Please do note that the tea breaks and lunch will be provided throughout the day, and stay until the end because we're going to have a fantastic reception at the very end for all of you. We also have an exciting lucky draw, so we'll be giving away 2 Amazon Echo Dots. So please turn in your feedback forms, and that's how you'll get entered into the drawing. We will announce the winner at 6 p.m. at the cocktail reception. So please stay till the end and turn in your feedback, and good luck with that. For the social media savvy, we would love it if you would join in the conversation and include the hashtag AWS PS Summit when you post about the summit. So, we'd love it if you would share with others what you're learning, interesting things you're finding out here during the day. So now, it is my pleasure to welcome our local leader who runs the public sector business for all of Asia Pacific and Japan. And he really has been building this business from the ground up for the last 4 years. So straight from the CNBC morning show this morning, please welcome to the stage, Peter Moore. Yeah.
Yeah, the CNBC morning show was a good warm-up. I'm not nervous about anything for the rest of the day. There's nothing like doing live television. So first of all, thanks everyone for coming along today. We have around about 1,000 people registered for the event today. We've got another overflow room if you're wondering where your friends are. They're in the other room out the back there watching it on the big screen. So once again, thanks all for coming. It's incredible to see the momentum that's happening in Singapore, and I want to talk a little bit about that today. I'm going to start with a quick update on the AWS business, give you an idea of what we've been achieving globally and here in Singapore. So Amazon Web Services has been around for 11 years now, and we're unusually customer focused, we're pioneers, and we're long-term oriented. And it seems to be working because today we are a $16 billion run rate company, and we've grown 42% year on year. In Gartner's most recent Magic Quadrant for infrastructure as a service, you can see that AWS continued to maintain the strong leadership position that it has, both in terms of completeness of vision and ability to execute. But what's really interesting, which you don't see on this chart, is that they said that they estimated Amazon Web Services is several times the size of the next 14 providers combined. So it's a pretty significant market segment leadership position. And so with that, we're very, very fortunate to have millions of customers, millions of businesses running on our platform around the world today. Startups have found AWS to be a natural choice for them in removing that burden that they would have typically had of the upfront cost associated with buying hardware to host their business. They've been able to get going without that capital up front. And that's why you can see majority of the world's startups today running on Amazon Web Services. But it's not just startups. It's also the enterprise customers that around the world, companies like Coca-Cola, Samsung, General Electric, and McDonald's, to mention a few, all running on AWS. What's important to these companies is that they have customers globally. And for them, they no longer need to build data centers around the world. They're able to take advantage of AWS global footprint and deploy their capability close to their customers. Also in ASEAN, in this part of the world, a large number of customers that we see. Many of these names I'm sure you're familiar with. So everywhere, but it's not just in the commercial space. Public sector customers around the world are flocking to AWS as well. We've seen them really take advantage of AWS to achieve the mission of public sector, whether that's in the government, in education, or in the non-profit space. And you can see that in Asia Pacific as well, there's a lot of public sector customers already using us. In fact, you'll get to hear later on in the keynote from GovTech, Singapore Land Authority, and the Genome Institute of Singapore, who'll be on stage presenting how they're using AWS to achieve their missions as well. So why does the cloud matter to public sector customers? Why have we seen this momentum? Well, there's two real reasons. One is they're using Amazon Web Services to pave the way for the disruptive innovation that they need. And they're also, the other important reason is they want to make the world a better place. We believe that in the non-profit space, in education, and in many of the things that governments are asked to do, they're making the world a better place. But let me dig into each of those. So first off, disruptive innovation. The demands that citizens have on governments are no less than what they have for taxi companies or for hotels. Grab and Airbnb, for example, are hosted on AWS, and they've completely disrupted those industries. But now citizens have those same expectations for government services as well. So governments need agility. They need to have the ability to try many things, pick what works. We sometimes call it building the airplane while you're flying it, but you can do that with Amazon Web Services. The second thing is capability. We innovate for you. You don't have to be thinking about all of the new areas of technology like IoT, artificial intelligence, machine learning. We do that innovation for you, and you can focus on your mission. And then the next is cost savings, obviously important to everyone as well. But what it really means is that you get more mission for your money. You can do more with the budget that you've been given. Not only that, but if your needs go down, you can scale down and you can make the appropriate cost savings associated with that capacity that you no longer need. That's not something you can do when you have a data center. So old world infrastructure can't really keep up with the rapid pace of change in the world today. It's quite shocking when you read the paper every day today, some of the things that are happening, whether it's atrocities of people shooting each other or whether it's natural disasters. Governments have to respond to these things, and they're finding it increasingly challenging. We believe that by allowing AWS to do that undifferentiated heavy lifting of providing the computing infrastructure needed to address these challenges, that the public sector has more time to focus on driving their mission and capabilities to respond to these very specific changes. So let's talk now about the evolution of cloud adoption in government. What is the typical journey that our customers have taken? And this has really been learnt from us over the last several years as we've seen countries that have really embraced cloud computing. What are the steps that they've taken? Where do you start from? So the first step is really definition. And sometimes I think we don't talk enough about this because people now are calling almost everything cloud. It's a bit annoying actually, because actually cloud is defined very clearly by NIST, the US Standards Authority, and they say there are actually 5 characteristics of cloud. The first is on-demand self-service, which is provisioning computing capabilities without human intervention. Ask yourself, do you have that today? Broad network access, available either over a private or a public network. Resource pooling, meaning that the resources that you need are pooled to serve multiple customers and you can take advantage of that scale. And then measured service, meaning that usage is monitored both by the service provider and by the customer so that you can actually have transparency over what you're using. And then that basically leads to a question. If you're not seeing all of those capabilities in something that you believe to be cloud, then I'm sorry, but it's not cloud. You need to see these characteristics, otherwise you're not getting the true value of what cloud computing can deliver. The next area I want to talk about is policy. And what do I mean by that? Well, we hear about things like cloud-first policy. In other words, let's use cloud for everything unless there's a really good reason not to do so. Or what about data classification? Have you thought about, the classification of your data so that you know the appropriateness of the security controls that you apply? Or what about privacy policy? Have you got specific requirements to manage how privacy-related information is accessed and controlled? You'll find that all of these things are a lot easier in the cloud, but you really need to have policies that are going to talk to these issues. Otherwise, you end up with a lot of people saying no. The next area is security and compliance. Really important. Mark's going to talk more about this in his keynote, but security, in Singapore, for example, there's MTCS, which is the standard for cloud security, multi-tier cloud security. Understanding what classification of data you have, how to apply security controls to that, how to manage access and identity, all of these sort of things. Again, you have to document that specifically for cloud, otherwise people will say it's just too hard. So really important to get that done. The next is acquisition, and even if you have all of the previous things done and you don't have any vehicles for people to buy cloud, then it becomes a real roadblock and it becomes challenging. So you need to have procurement vehicles, you need to have contracts, you need to have in place easy ways for people to buy, because it's no good having all of these benefits of cloud that I've talked about if you don't have an easy way for people to buy it. You need to have the opportunity for people to move away from thinking just about upfront capital expenditure, and you need to be able to move to an operating expenditure model. And I've heard procurement people tell me that's too hard, but somehow they pay for their electricity bill every month. So it's no different. The next area is skills and culture, and actually this is sometimes the most difficult part. How do the skills need to change from that undifferentiated heavy lifting of maintaining infrastructure to the higher level skills that are necessary for governments and educators to really do a better job of achieving their mission? How can you get the technical people thinking about serving the citizens, about solving the problems, instead of worrying about hardware drives failing or running out of storage capacity? So this is really giving people an opportunity. It's not about people losing their jobs, it's about creating new opportunities for people to do more fulfilling things and take that undifferentiated stuff away. And then finally, broad adoption. No one really wants to go first. It always takes someone brave to go first, but that's happened around the world now. So you're no longer the first person to do this. look at the examples that you'll hear from our customers today. You don't have to be first anymore. So be fast followers and go public with success, and broad adoption will follow. For us, having such a broad customer base across so many different scenarios, from the most highest levels of security to, easy access for a startup to build a little application, that's really important, because that global scale and global capability that we've built can be used by customers around the world instantaneously. Now, we've had tremendous progress in Singapore's public sector, and I want to give you a couple of examples of that. We have a program called AWS Educate, which is a program that we're using to help with the skills challenge that I talked about. So every public university and institute of higher learning in Singapore today has signed up for our AWS Educate program, meaning that students in every higher education institute in Singapore are getting the skills for cloud computing, so that when they enter the workforce, they're going to be useful and they're going to actually have very valuable jobs. And we've actually seen surveys that show that people with these sort of skills get much higher salary than people who haven't. The other thing is, we've identified what people are interested in, and we have what we call career pathways in AWS Educate, which gives people a guide on what to learn in order to achieve a certain career discipline. And the most popular career discipline, you probably could guess it, but it's data scientist. There's so much data out there, and people are trying to take advantage of data to make more informed decisions. And so data scientist has become the most popular career pathway in universities for people learning cloud through AWS Educate. And then, I don't have to say more about the momentum in government here, because we have 3 great customers on stage today. We have the Genome Institute of Singapore. In the research side, we've got Singapore Land Authority, and we have GovTech, who will all be presenting on stage today. That's how we demonstrate momentum with our customers. We let them tell their own story. There's never been a better time to build for people who have the skills to know how to build stuff with cloud. In 2014, we had 516 significant features and services that were launched. In 15, it was 722. And in 2016, 1,017 significant new features and services released. That's more than one every day. And these are significant. These are not just little changes to a product or a service. These are significant. So it's tremendous, the momentum that we've got from the pace of innovation. Today, we don't have any conversations about if. Every conversation is about when and how. And there's a whole generation of builders out there today that are taking advantage of these features to build incredible new applications, taking advantage of that capability that we have delivered to our customers, the breadth and depth of capabilities. So with that, I have a very, very special announcement to make. This pace of innovation is happening globally, and specifically in Singapore. I want to announce that Amazon Glacier is now generally available in Singapore from today. I'm glad you're excited, because we've had a lot of people asking us for this. It's incredible to be able to bring this to government, education, healthcare, and research customers who have been waiting for this for a long time. Amazon Glacier, if you don't already know, it's an extremely low-cost, powerful, and flexible data storage solution that can address the full spectrum of your archive use cases, ranging from deep archive to things that are never retrieved, through to use cases where you need minute-level access, like media broadcasting, petabyte-scale content distribution, and big data analytics. So a couple of extra things about this. Data stored on Amazon Glacier in Singapore is going to cost you less than half a US cent per gigabyte. This low price is as a result of the scale that comes about when our customers trust us with the trillions of objects that are stored in our Amazon storage today. But it's just one of those benefits. 3 options for retrieval are available: standard, expedited, and bulk. And it makes it more easier than ever more easy to and cost effective to access your data. You can also deploy compliance storage controls with Vault Lock to store regulatory and compliance archives, because we provide immutable write once, read many options within Glacier. 11 nines of durability. That's a lot of nines. I'm not even going to try and say 11 nines one by one, but in mathematical terms, 11 nines of durability means that out of 10,000 objects that you store, you might expect to lose one every 10 million years. So that's pretty good. All data is encrypted at rest, and Glacier offers a suite of features from compliance to audit logging to cost management. So it's a really comprehensive capability. So I wanted to finish with that good news for all of you. Thank you very much for being here, and thanks for paying attention. There you go.
Thank you so much, Peter. All right, our next speaker, I'm very excited to have him join us on stage. Mrs. Mark Schwartz, and he is an enterprise strategist. He's very new to AWS, but this is the second time I've shared a stage with him, because he spoke as one of our customers when he was an innovator in the US government. He was the CIO for Citizen and Immigration Services in the US Department of Homeland Security, and really was moving things forward very quickly. Since then, he has authored 2 books about the impact of DevOps on enterprise strategy. So please welcome to the stage, Mark Schwartz. There you go.
This is my clicker. Question. So why aren't governments more innovative? It's an interesting thing to think about, I believe. Let me tell you a little story from my background. About a year ago, when I was still with the US federal government, I was asked to take charge of a large project that just wasn't doing very well. It was kind of well known as something that wasn't working. So the first thing that I did was I sat down with a number of the leaders of the project, and I asked each one individually, what do you think we could be doing better to make this more successful? And each of them, without fail, gave me great ideas. One of them said, well, it seems like we're just automating paper processes and we're not doing anything innovative, and then proceeded to give me a whole bunch of great innovative ideas. Another one said, we're not really listening to our customers, we're not really listening to the users, and then here's what the users really want. So I was amazed. And I think the thing that really stumped me, I asked each of them, why aren't you doing those things now? Or why haven't you been doing them? You know exactly what to do. Those are all great ideas. And what I found is they had great reasons why they weren't. They could list for me obstacle after obstacle. Well, there are too many people who can say no, and the process is so complicated to get a change made, and on and on like that. And so I realized that the issue wasn't so much having ideas, the issue was letting those ideas sort of blossom. So I asked them, why didn't you ask me for help? Or why didn't you ask somebody for help? I could have helped you with those things. And they said, without fail, each of them, we didn't think you would be able to do anything. We didn't think there's anything that could be done about these things. Bears thinking about, right? So I think the biggest impediment to innovation, from my observation, is a sense of learned helplessness. That people realize that their ideas are not going to go anywhere, and so after a while they just stop even mentioning their ideas. And I've seen this over and over again. So why aren't governments more innovative? Let me sort of describe to you what it looks like when somebody has a great idea, how we make it into a reality, right? So here's the idea, here's the reality. What do we do in between those two things? I'm going to talk about the US government, because that's where my experience is. And I'm sure that you don't see any of these things in Singapore or Malaysia or any of the other places that you represent, but I'll just talk about the US government. So here's one of my employees. They come up with a brilliant idea, and now we're going to turn that into a reality. What's the first thing that we do? We wait. Why do we wait? Well, we wait because we have a governance process that is set up to approve large projects and programs, and one idea by itself isn't good enough, so we have to wait until we have a lot of good ideas. And then we put them all together into a major project or a program. And then we can put it through our governance process. Now, when we have a lot of ideas all lumped into one big program, of course, it becomes expensive. And when it becomes expensive, it becomes more risky. And when it becomes more risky, we have to apply more oversight to manage the risk, right? We have to make sure we're not going to waste the money. So the first thing that has to happen is we have to set up this big program and start putting it through an oversight process. And so we turn around to the person who had the brilliant idea and we say, okay, Mr. Innovator, now you have to write 104 documents and go through 13 gate reviews in order to get this idea approved. That's actually what our acquisition process looked like in DHS. So go ahead, 104 documents, 13 gate reviews, and finally at the end of that, maybe somebody says yes, and then we can start the process. All right, so we've taken this much time so far. Next step is that we have to procure. We have to start doing procurements, tenders, RFPs. So we would procure the hardware, and then we would order the hardware and wait for it to be delivered, and then we would procure services to stand up the hardware, and then we would onboard the people who were going to do that. They would set up the hardware in the data center, and then the security people would come in and secure it, and then finally we were ready to start working on the idea. Okay, so now this much time has passed. And then we would procure development services, and of course we'd have to do security checks on all of the developers because they might be bad guys. And finally they would start work, and they would do some development, and then somebody would do some testing, and then the government would do independent testing to make sure the first set of testing was good. And then the security people again, and then we would have a change control process. And so by the time this idea actually got into production so that people could use it, decades had passed, centuries, I don't know, like this, right? So think about what this is like to the person who has the brilliant, innovative idea, right? They're probably long gone already working for a company in the private sector where they can make lots of money or whatever before anything happens. So why isn't government more innovative? Let me tell you about some of the things that we tried in order to get out of this horrible cycle, that was clearly stifling innovation. At U.S. Citizenship and Immigration Services, we moved to a DevOps process. So with the DevOps process, we had cross-functional teams that represented all the necessary skill sets, and they worked together to quickly create functionality. And then we had an automated process, a very automated process to automatically test anything that any coding that they did, and to integrate all of the work of the different people working on a project, and to automatically deploy the project. So we were able to start turning around functionality. Instead of releasing new product every 6 months or a year or something like that, we would have multiple deployments every week. We were tending towards about one a day. But that's not really the thing to focus on, how many deployments and how quickly. Really, the interesting thing is to go from idea to something that could actually be used. We were shrinking that time quite a lot, right? And that's what matters for innovation. So the enabler for all of this, what made this all possible for us was our move to the cloud. Because what we could do in the cloud is, instead of going through that process of procuring and installing hardware and all of that, we could spin up new environments in the cloud, new servers, in just moments. So every time we wanted to run a set of automated tests, boom, we create a set of infrastructure for it, run the tests, tear it down again. And then do that again and again, continuous integration during the day. Every time a change is made, same thing. So we could shrink that, what was actually a 9-month cycle to get that hardware in place, we could shrink that down to just moments. But that's just the beginning of what we could do. We could also use higher level services that were provided in the cloud as another way to shrink the development time. So for example, we used IAM, we used EMR, we used ECS, we used a whole range of Amazon services, further shrinking that cycle time and getting results quicker. So that was the beginning of the journey for us. A lot of people wonder, how did we just suddenly switch gears and start doing DevOps and start doing agile development? This is actually the easy part when you're CIO of a large government agency and you have a lot of, say, hierarchical power. One of my superpowers that I had was that I could just write policies, right? So I wrote a policy saying, we're DevOps now. I don't know. Nobody questioned it. It sort of worked. I recommend that approach to anybody who actually has the ability to do such a thing. It simplifies a lot, but it leaves open a very important aspect, which is cultural change, let's call it, for lack of a better word. The real benefit, once you start to get into this mode of constantly being able to produce things quickly, see results quickly, is a change in how you think about new ideas and what you can do with them. By using this approach, what we were really doing is reducing the cost of implementing a new idea, and especially reducing the risk of implementing a new idea. Right? And so suddenly, it became possible to support ideas that we would have had to put a lot of thought and planning into to make sure they were good ideas, because we weren't risking very much at all. And that cultural change, once it starts to take effect, it changes how you think about innovation, because it becomes a question of experimentation, not just having a brilliant idea and being able to write a business case for it and so on. So let me explain that a little bit more. I've been an IT leader for a long time, and I want to tell you something about IT leaders. This is a big secret that I'm going to give away now, which is that we think we're really smart. And really, we think that it's our job to be smarter than our employees, of course, right? And so when an employee comes up with a new idea, what do? We ask them questions, and then we ask them harder questions, and then we start pointing out all of the flaws in their idea. We say, did you think of this? Did you think of this? Did you talk to this person? Because that's what you do when you're a leader, because otherwise, what value are you adding, right? You're not actually creating anything. So it turns out, I discovered this eventually. It might have taken me 20 years of leadership or something in my career. I realized that sometimes, unbelievably, I'm wrong. And it's kind of an important lesson. So with this sort of rapid turnaround, low-risk approach to innovation, instead of saying no to ideas, I could just hold myself back, restrain myself, and say, prove it. Here you have a great idea. Okay, here's my credit card. Go spin up a virtual machine in AWS and show it to me. And show me why it's a good idea. And try to get some users using it. And show me that they like it. That way, if, I might be sure that it's a stupid idea or whatever, but I might be wrong. And this way, we can prove it out, test it, and gather actual data to decide whether it's a good idea or not. So the task, instead of doing a lot of analysis of whether something's a good idea, the task is, can you define the smallest possible experiment that will give information about whether it's a good idea or not? The smallest possible experiment with the least amount of risk that you can do really quickly and decide whether it's a good idea or a bad idea. That way, my opinions don't get in the way. In fact, my job then becomes removing impediments. Back to my original story, the reason why these people couldn't do the things that they thought were the right things to do is because it's just impediment after impediment after impediment. So if I saw my job, instead of being say no to everything just in case, or point out all the bad things about what somebody is doing, instead my job is figure out how to clear impediments for them so they can do what they want to do. Clear political impediments, office politics, bureaucratic constraints, lack of resource, not having people with the right skills, all of those things. If I could clear those things out of the way, then my employees could innovate. And these ideas that they already had in their heads that were good ideas, those could actually come out and become reality. And that really is what the cloud is all about. That is why I decided to join AWS, for one thing. Having done this for a while and seen the power of it, I wanted to be involved in what I think is truly a revolution for the government and exactly the missing piece for being able to encourage innovation. So my message to any of you who happen to be managers or leaders here is that you probably already have a lot of innovative ideas in your organization. What I ask is that you find these ideas and nurture them, because there are already so many things that are getting in their way. Thank you.
Thanks so much, Mark. All right, for our next speaker, I know that you are going to enjoy hearing from him. We have Mark Ryland, who is the technical leader for the public sector business. Mark is our chief architect, and he has been with the company for 6 years, which in any other organization would probably be about 25 years. So he's really been building this business from the ground up from the time that we put a focus on public sector. So please welcome to the stage, Mark Ryland. Yeah. Yeah.
Everyone, it's great to be here. Thanks for joining us. Again, my name is Mark Ryland. I'm the chief architect of the public sector team, and I have the privilege of guiding you through the rest of the keynote presentation this morning, which will highlight business areas, innovative ideas, technology topics, perhaps most importantly, some great presentations from our customers. So how do we characterize or summarize the capabilities the cloud can provide? And based on feedback from our customers, this may sound a little over the top, but we think of it as providing superpowers. What we hear from our customers is they can do things they never thought they could do before. Leap tall buildings in a single bound. They can have bulletproof capabilities, X-ray vision. Of course, I'm exaggerating a little bit. But the point is, the cloud is not just a sort of step function or a minor evolution in IT capabilities. It really is a profound revolution, like you heard from Mark in the previous presentation, which can dramatically improve costs, efficiency, and really agility and ability to treat IT as an experimental process is a revolutionary capability that our customers tell us is just changing the way that they can provide and deliver their mission. All across public sector, we hear these stories, and we get to participate in these wonderful capabilities and mission improvements that we're going to talk about. So how do we define public sector at AWS? We define it quite broadly. So we define it as all forms of government, national, regional, local, the entire world of nonprofit institutions of various kinds, as well as non-governmental organizations like UN, World Bank, IMF, and so forth, and education of all kinds, public and private, the K through 12, as we say in the US, the lower grades, universities, graduate and postgraduate. All of that is part of our public sector business. And that gives us a very broad view of what's going on out there in the world of cloud and the ability for people to achieve missions in a really dramatic and powerful new way. So this is a kind of outline of the rest of our talk today, our time together, as we're going to talk a little bit about government with some examples. We'll talk about the non-for-profit world and education as well. And we'll alternate between talking about technology, which enables these new capabilities. At the same time, we'll shift to talk about business processes, mission, and delivery of new capabilities, and solving real customer problems and customer use cases. So you'll find us kind of going back and forth between these two dimensions. So let's start with government. Government is really core to our business. It's core to the lives of everyone. We all live in societies which have governmental authorities, and having government be efficient and effective in achieving its missions is really an important thing for all of us. And cloud can really help in many, many ways. Now, at the base of all of these missions is data. So we have to acquire data, we have to store it and manage it in an effective way in order to succeed in any of our governmental missions. And one thing cloud does is provide a wide range of very powerful storage solutions. So we'll take a kind of technical slant for a second on this problem of government and IT. We've already heard this morning about the launch of Glacier here in the Singapore region, which is a very exciting new capability. Glacier provides extremely durable, extremely low cost, and very well-governed capabilities for your archival storage. One thing Peter mentioned, I want to just drill in on. One thing that's quite a powerful capability is the ability for something we call vault lock. You can actually write a policy and apply it to your Glacier storage environment, which makes it write once, read many. Literally, you cannot delete the data that you put into the storage once you create that policy. That may sound kind of odd, and it took us a while to think about the right way to do that. But there are many requirements that policies, for example, financial institutions, governmental institutions, that are required to keep data in some form that cannot be altered. In the early days of cloud, there was the question like, wait a second, what if someone's the root administrator of this account? They have some certain powers. We can't deny those powers. But we heard from customers again and again, no, we actually want to be able to create policies that make it so that we cannot delete the data that are in these archives. So we came up with a model for doing that. And then as long as that policy is effective, it can be time-bound, it can have various constraints around it. You can literally store data in a way where even your most powerful users cannot delete the data. Think for a moment about the security implications of that. That's pretty handy. If you take some of your archives and your logs and your security information and stick it in one of these vault-locked archives, even a powerful user in your environment who perhaps is interested in doing something they shouldn't do won't be able to change the data or alter the records of their own behavior. So really powerful. And in addition to Glacier, we have our S3 storage service, Elastic File System, many, many other storage solutions that enable you to manage and use data very effectively. Now, what are people doing with that? So let's switch from the technical view to the business view. And a big part of what people are doing with cloud are these large-scale transformations of government into the digital age. We see this around the globe. We see government recognizing that, as Peter mentioned earlier, our citizens are consumers, and consumers have totally different expectations today than they did not long ago with the speed of access, the ease of use. The so-called consumerization of IT, you may have heard that phrase. And it has a number of different ramifications, but one of them is that people expect services to be easily available on their mobile phones, easily available from portals, and to get that kind of access and to satisfy those requirements, governments now are completely changing the way they do business and making it much easier and much faster to provide citizen services using cloud technology. So with that as the background, I'd like to invite to the stage Mr. Tan, who is the Senior Director at GovTech Singapore, who will talk about some of the innovative work happening right here in Singapore. Mr. Tan.
Good morning, ladies and gentlemen. It's indeed a privilege to be invited to speak at this AWS Public Sector Summit. First, I'd like to just quickly introduce GovTech, the Government Technology Agency of Singapore, where I come from. GovTech was formed about a year ago through the reorganization of IDA and MDA in Singapore. And we're now reconstituted as a part of the Prime Minister's office under the Smart Nation and Digital Government Group. Our charter covers a broad spectrum of work. We collaborate with various agencies in terms of the verticals, whether it's healthcare, whether it's transportation, whether it's living environment, in terms of a range of strategic projects in the verticals. We also build a number of horizontal platforms at the national level. National identity is one of them. Electronic digital identity is one of them. Census platform. Within the government, we also do a range of infrastructure projects. Many of you are familiar from the Singapore public sector, whether it is a data center, whether it's government network, whether it's email services. We also worked on promoting the development of engineering talent within the Singapore government. So, in the context of this discussion, I'd like to share a thought by the Prime Minister in February this year. He publicly stated that he thinks the pace of smart nation and digital government ought to be a lot faster, given the amount of effort that we put in. So internally, the Prime Minister has also set us a target to improve a lot of our digital shopfront experience. I think many of us from organizations know that we do public-facing services, websites, etc. So the Prime Minister has sort of commented that government agencies can do a lot better in that area, in improving the user experience. So that gives the context to why CWP is relevant, the Content Website Platform. This is an infrastructure that we set up in the end of 2016, leveraging the public cloud technology, putting together a set of services, security, operations management, selected set of CMS, content management service systems, content management software, in order to help our organization roll out websites in double quick time. And you will see from there a range of benefits such as convenience, such as security, using less resources, being able to deploy a lot faster, as well as there's economy of scale leading to cost saving. In the next few slides, I will elaborate a lot more on these areas. So I choose to cover this in covering architecture, covering operations management, as well as how we do the security. Many of us, looking from the left to right, many of us are familiar with our own hosting environment. In the past, we set up a data center. We do everything from ground up. Basically, you have to be responsible for managing all the way from storage servers at the infra level all the way to your services, be it whether it's interaction or transactional systems or just websites. And then enter the middle tier or the middle possibility of doing it on a private cloud structure, where parts of it is essentially managed for you, but you still do at least half the stack. And on the right-hand side is what we propose or what we have implemented as a content website platform, where you basically do nothing except managing your own websites and everything else is done for you. And through that stack of services that we sort of integrate and manage centrally, you will be able to achieve manpower saving, you will be able to achieve cost saving, as well as time savings. This is a busy slide, but since I'm invited to the AWS Summit, we must mention how we leverage AWS services. So on the bottom right, really, I think this is to demonstrate how we make use of the relevant AWS services to roll out a platform like CWP. And you can see from there that there's a range of useful utilities and services provided by AWS. In particular, the elastic load balancing part on the bottom right. It has allowed us to, working with our service provider, ExtremeX, to do auto-scaling in a very dynamic manner. And later I'll elaborate how that effectively saves time. On the bottom left is we have selected 5 CMSs, content management software. And unfortunately, we are unable to service all, but we decided that we will do the top 5, which has the highest utilization rate in government. As a suite of offering expense, I think the manageability and the difficulty also sort of escalates. So we decided that for start, we'll do 5 CMSs. And the middle tier is really where the value add starts. right? So leveraging AWS services, working together with our partner, we have actually rolled out a range of subscription services to portals, to where you can sign up. You can then decide what tier of service you want. When the code is ready, you can actually deploy it for testing, as well as to turn it on for security vetting and production. The top tier, no surprise, I think is what many of us do. We rolled out a bundle of security services, whether it's your CDN, whether it's your VA services, whether it's your penetration testing services, whether it's your defacement monitoring. And we have all of that integrated together. So that saves time, and you don't have to go around shopping to different purchases. And where there are content that requires a different class of security, I think we go to sanctioned hosting environment, at least for the Singapore government. Operation savings, operation benefits. In this area, we classify into 4 areas. So what we've done is that if you signed up for the website, it is a very simple process. You go to a portal, you ask for an account. Once it's approved, you can actually start subscribing for the tier of service that you want, whether it's small, medium, large. It's very simple. And after you subscribe, you decide when it should be stood up. The infrastructure, whether it's staging environment, whether it's production environment, will then be stand up for you, right? And then once that's done, your developer can actually start putting his codes. The website developer can start deploying his codes. And he can actually develop there, or you can put what he developed offline onto those portals, and then it can be ready for testing. Bundled in the CWP is the service provider's vulnerability assessment, as well as penetration testing, using both tools as well as third-party manual penetration testing bundled into the CWP. So we also do that for you. And once the website is tested, is ready, security vetted, the agencies can actually decide to deploy, right? And it's again just redirecting your DNS to point to the production website, and then there you go, you are live, right? So in summary, that's just a 4 steps process. How long does it take? We have agencies like Vital, which we cited this year for sharing that a corporate website like Vital was able to be accomplished from signed up to go live in 7 working days. In total, if you look at the dates, it's about 9 days, right? Including a weekend. They're able to do this because, first of all, the website was well developed, well tested. There's no security vulnerability. But if you do have security vulnerability, somewhere along the way we will check. We say, sorry, it's not good enough. You have certain loopholes. Please go patch them and come back again. But this one was very good, and was able to, in one pass, finish it. And we were able to complete this within 7 working days. You may say that that's still not good enough. So I was discussing with my colleague, what's the best case that we have had? And then they told me, 1 working day. So I said, 1 working day, is that really possible? They say, yes. There was a particular program website that a particular agency wanted, and it was done within 1 working day. But we don't want to use that as a standard norm, because that's really not the norm of things. Because in the normal corporate websites, you do have development, you do want testing, you do want somebody to vet, etc. So we will say that 7 working days is probably the kind of benchmark that we'd like you to sort of appreciate. And I would say that having done many of these things, 7 working days is quite an achievement, given that you have otherwise have to do procurement, you have to put through for testing and vetting, etc., and then you have to have the infrastructure in place. So it is quite an achievement, at least in our view. What are some other areas of operations efficiency that we have managed to do? I wanted to share 2 areas. One is really about the capacity scaling. I think many of us running websites, especially large websites, you do have peak loads. And sometimes the peak load comes at very inconvenient time, or even unpredictable time. And so how do you prepare for it? Traditionally, you will buy all the capacity that you need, just in case. But that just in case comes at great cost, and it comes at certain amount of pre-planning as well. So with the cloud infrastructure, we are able to set the threshold, monitor the usage, and say when the threshold of utilization reaches X%, I want you to spawn off a new instance of infrastructure. And that can be achieved by copying from the S3 storage, both the codes as well as the config information. And then the instance is spawned up, and then it can be connected to the load balancer, and it goes live immediately. And that is one way of covering the various areas of instances that is required, from websites to apps, etc., to even proxies. The advantage is quite obvious. I think with that, there's little to no downtime. We're able to actually allow to handle load searches in traffic. And as a little sort of benefit, we have also discussed with the service provider that if it's only for a very temporal thing, in fact, it will be no cost. Yeah, but I think the main appreciation here really is that the ability to scale it very, very quickly without the need to without the need to go through hardware acquisitions and all the setup again. The next area is about security, patching. I think many of us in operations knows that we constantly have to keep doing all the security patches. Each time a vulnerability is announced, I think you run to patch to make sure that it's not being exploited. So in this instance, what we have done is we have the ability to do those patching offline. So you have a similar instance, you patch it, and then you connect it to the load balancer. And with that, once it's connected, you can actually remove the one that is obsolete, that is unpatched. And bingo, you are good to go, right? It sounds very simple. And my point is that why weren't we able to do this before? Why did we have to announce a maintenance period, X hours, X hours maybe, patch it, and then we got to bring the service back online. But with this, it can be almost no downtime, right? But it's also the speed that we're able to do this. I think the patching was able to be done in minutes rather than hours. And we actually measured some of the instances that we had to do, and it was 7 minutes compared with 1 hour, and thereby about 8 times the efficiency. Yeah, and I think many of us will appreciate the little or no downtime. That, in fact, is even more valuable. Last but not least, the security area. I think many of us doing websites, especially in the heightened cyber security landscape, know that the amount of security that we have to do is probably takes more effort than the website itself. And here is just one simple diagram to sum it up. I think from the parameter in, you have all the necessity to doing your cyber watch, to do your CDN, your WAF, your defacement monitoring as the outer tier. So through the CWP platform, we actually have integrated all that in as the basic services, all bundled. In the middle is then the usual things like vulnerability assessment, penetration testing. I mentioned that earlier that it's also as part of the standard package that we provide, at least at the time that the website is first time being stand up. We also do quarterly scanning, vulnerability assessment at the network and infrastructure level to make sure that all our underlying infrastructure is sound. And then the middle tier has got other aspects of the cyber security measures as stated there. But last but not least, I think what is also important is we leverage AWS multiple availability zone in Singapore. And that itself provides another level of increase in resiliency. A case in point was that in January this year, WordPress had a vulnerability that was exploited worldwide. 1.5 million sites were affected. Well, we were lucky that we were watching this very closely, and we were able to do this in a total elapsed time of 23 hours. In fact, the actual time is taken there is only 9 hours, but I think it's some of the testing effort taking in total of 23 hours. And the ability to patch very, very quickly is what's going to separate the vulnerable and the ready. Because according to Gartner, a lot of the exploits, more than 90% of the exploits, will continue to be these known ones. Everybody knows about it. It's who can get to the finishing line faster, whether it's the hacker or you. Right? If you can patch it faster, your site is saved. So where do we go from here? The current offering on the left-hand side is for websites. We have about 400 websites We will have about 400 websites by the end of this year. Now about 380. Moving forward, what we want to do is to really provide services to the mobile platform through API hostings. What do I mean by that? I think for the Singapore agencies here, you will have heard of what we're rolling out in the form of CalSync, which allows a calendar to be loaded into the officers' personal handphones. And the back end of that really runs on CWP. And similarly, we're also working with MOE to do some of these applications on the mobile phones through the native apps, but connecting back to web content that are hosted on CWP. On the right-hand side, moving forward, we hope to be able to roll out software as a services in area like learning management, in area like email, mass communication or marketing emails, right, to the public. So, in summary, I just want to quickly share a few accolades from our agencies, our customers, our agencies that make use of CWP. Basically, I think the cloud platform has allowed them to achieve cost saving, transparency, time saving, and without the need to go multiple places to source for all the security and all the purchases. So it is a lot of convenience, it's a lot of efficiency gained. So on that note, thank you very much.
Thank you very much. That was an excellent presentation showing the power of the platform and the use of modern technology to really speed up delivery and actually increase security while we're also driving down costs and improving efficiency and ability to deliver services. So very exciting. Now let's go beyond digital government. Let's shift back a little bit now to a security and compliance focus. This is a really important part of the cloud story and one that's probably not yet fully and well understood. When we started this journey, and I started 6 years ago, and we would talk to customers, we couldn't have more than 2 minutes of a conversation before people would say, well, what about security? It's just the most natural and obvious question. It's a new type of technology, a new set of abstractions. People are not accustomed to it. It's a very natural thing to wonder, to question, and to ask hard questions about, can this new technology provide the kind of security that we need? And the answer is yes. And a big part of that answer is compliance. Now, why is compliance and third-party accreditation so important in the cloud era? Let's step back for a minute. We're a cloud vendor, and we make all kinds of claims about our platform. We claim it has all these great encryption features, all this amazing ability to log all the API calls, to surface logs from all the services. Very powerful, feature checklist of amazing capabilities. But we're a vendor, right? So you might say, well, how do I know it's true that you do all the things that you say that you do? Now, in a traditional world, if you were buying equipment and putting it in a data center and maybe using colo or doing outsourcing, you would hire a team that would personally and directly test the claims that were made by the outsourcing provider, right? You would go and test the biometric locks on those data centers. You would do penetration testing of the servers. You would ask to look at the source code for the services. You would have this kind of direct access to these capabilities. Now, let's switch to these hyperscale cloud platforms. We have over 1 million customers. Is it reasonable and is it actually safe to assume that millions of customers could do that same type of direct personal interaction with a platform? It's not real. You couldn't actually do that, and in fact, none of US customers would want other customers to be able to do those things. So how do you square that circle? You've got vendor claims on the one hand, you have a very reasonable need to know the truth about those claims, and the way that we do that is through a very rigorous third-party audit and compliance program. We operate under the scalpel of professional auditors who have constant access to our environments, constantly watching our operations, constantly checking our supply chains, and producing reports and evidence that you can read, that your experts can look at and ask further questions which we'll clarify, and then you can rely on that whole ecosystem of third-party accreditation to feel comfortable that the claims that we make are true and actually real. So every auditing regime that we operate under, they have many similarities, much in common. For example, we'll talk a little bit more in a moment about here in Singapore, the government MTSC program, IRAP in Australia, FedRAMP in the United States, plus a ton of commercial regimes as well. PCI DSS for the credit card industry. The motion picture industry actually has a very rigorous security regime. Have you ever thought about that? Isn't that strange? Why would the motion picture industry have a very rigorous security and audit and compliance model? Because the value of digital movies is extremely high. If I can steal a copy of a digital movie, I may have taken the tens of millions, if not more, dollars from the bottom line of a movie company. So the movie industry is a very tough customer. And one of the earliest and toughest audit regimes that we undertook some years ago was the Motion Picture Industry Association audit regime. So between that and between the auditor-to-auditor reports, the SOC compliance, so-called SOC compliance, the Cloud Security Alliance, and dozens more that aren't pictured on this slide, we have auditors all over the place taking a very, very close look at our environment and producing reports that you can rely on as you make a decision about the security and reliability of the cloud. So this is really critical to the model here. Now, here in Singapore, we were the very first large-scale cloud provider to achieve this MTSC accreditation now 3 years ago. And we're very excited to have that, and it's enabled a lot of great government workloads. That is a 3-year cycle. We've just gone through the second round of accreditation in 2017, and we're very proud to announce that we have met that certification to host and process confidential data, and we were able to expand the number of AWS services from, in the previous round, 14, and we added 19 more, so now we're up to over 30 services that have been fully accredited by the Singaporean government. So very exciting capability and one that you can really count on. So as I said, when we go with customers on this journey to the cloud, they first ask very reasonable questions about, hey, it's a new abstraction, I don't really understand how this works, can you explain it to me? They go deep with us, they learn about the capabilities, learn about how we operate, learn about the evidence that we provide that proves how we operate, and then they look at this very rich set of features that do things you could never do on premises realistically. For example, configuration management, extremely hard to do in a physical environment. Every time someone makes a change to a server, changes a route in a router, changes a setting in a switch, is it possible that they would then log into a configuration management database and record their change so that your database was exactly accurate? Is it possible? Yes, it's possible. Does it ever happen? I don't think so. I don't think it ever happens that a manual process of change management or configuration management in a database which purports to reflect the state of your physical environment is highly accurate. Think about how clouds operate. Think about how our cloud operates. It's a software-driven environment. So when you call an API to launch a virtual server, you may think, okay, well, the API launches the virtual server. Well, it does, but that's not exactly how it works. The first thing that API does is it updates a database. And then a workflow, seeing the change in the database, launches the virtual server. So what does that intermediate step mean? It means that we have precise configuration information about the state of your environment at all times because it's actually logged and controlled in a database prior to it being instantiated in physical reality. So when we make a record of those changes in our configuration system, you can get extremely accurate and reliable information about everything going on in your environment that you're calling our APIs to change. So very, very powerful. And so we get results like this. Once we go deep with customers, once they understand the platform, we get quotes, and I can multiply these endlessly, but one from very recently in Australia at our summit there, one of the speakers on stage talked about innovation in the cloud and gave a quote saying, the biggest risk they believe now is the legacy systems, not the cloud systems. And we get this type of feedback from the UK government, from the US government, and more governments around the world. So now, security and compliance, just touch the surface there. We'll go deeper in some of our breakout sessions. Encourage you to attend those. But it's a critical part of the story of the journey to the cloud. But what is now, switch now back to the business focus from the technical focus. So business focus again, data-driven solutions. So this is the area where cloud technology really enables some really innovative and powerful new things. With the storage capabilities, the compute capabilities, the analytics that you have in a cloud platform, you can now move to a much more data-driven model where the decisions you make are based on analytics and powerful tools, machine learning and artificial intelligence, which we'll talk about later, and move from a more manual era, from a more judgmental era where human judgment, as important as it is, was the only thing we had to rely on, to an era now where, based on data, we can make decisions that are much more certain and much more reliable. So I'd like to bring to the stage now, as our second guest from the Singapore government, Mr. Ng, who's the director of the Geospatial and Data Division of the Singapore Land Authority. Welcome to the stage. Great to see you. There you go.
Good morning, everyone. I feel great to be with you today, but I'm going there to speak. Not that I want to stand out from the crowd. I want to stand more firmly in this cloud. Well, this morning I will share some of my thoughts with you on these questions. What is geospatial? How is it growing? What has it got to do with cloud? And one very important question. What is the name of the best map in Singapore? No, it doesn't start with G. Definitely, absolutely, it doesn't start with G. I'll tell you later. Anyway, geospatial information, science and technology, or I'll just use the word geospatial, it has been widely identified as the key enabler to support evidence-based program operation, decision-making, and service delivery. And why is it so? It is because the geospatial value proposition that enable users to make sense of the large realms of locational data collected voluntarily or otherwise. And geospatial can organize these large and disparate data sets on a common locational reference, and we can use it to overlay, interconnect, and analyze the data sets from different domains for decision making and reasoning. The geospatial industry has grown rapidly in recent years with an estimated compound annual growth rate, CAGR, of between 8% to 70% from 2016 to 2023, according to Ingwood Research in a 2016 report. The expected CAGR for the global geospatial analytics market is estimated to be 17%, signifying the very robust growth trend and the vast untapped potential in the geospatial industry. The rapid growth is evident from the many applications that are leveraging on geospatial information to provide services and consequently disrupt certain industry. So you are familiar with some of the examples. Booking a transport and tracking where they are. In fact, I took one this morning. They are all now done with location-based application. You can also know the eateries offering delivery around your location. And as a result, consumer choice has widened, and so is the catchment of the eateries. Well, my team member gave me an example. See, dating apps now enable you to find your identical matches near where you are. I swear I don't know about it. I have not tested it. Maybe you have. Maybe I should try. Now, this location-based services and application leverage on the where information. The where information is what some say the new language of commerce today. Now, adding such new geospatial dimension and capabilities in commerce and trade translate into an unprecedented amount of data being generated, according to an estimate by the United Nations Committee of Experts on Global Geospatial Information Management, of which I'm a member. 2.5 quintillion bytes of data is being generated every day, and a significant proportion of it is locational data. So organizations are not just looking into ways and technologies to visualize and analyze this massive amount of data, but also to efficiently store and serve them out to the stakeholders and customer. So this is where cloud hosting services are able to complement the heavy nature of geospatial data and capabilities. The massive amount of location information, the base maps, and all the features and data that come with our physical environment and the various business and people data need fast and reliable computational power. So if the where information is the new language of commerce and trade, then I would say cloud is an enabler for this language to be widely spoken. Not just the new location-based business are being enabled by it. Public agencies are also relying on these disruptive cloud technologies. So the new one map, of which I'm very proud, because it's fully developed in-house by a very hardworking team using open source geospatial software and on agile methodology. The one map, I think, no doubt to me, is the best map services in Singapore. So the name actually starts with O. And it has the most detailed, comprehensive locational information and also a whole of government platform for agencies to deliver geospatial information and services to the public. Allow me to briefly mention what the new one map can do. Some of the platform new offerings include a variety of base maps and to choose from, finding more than 100 thematic information layers, and it provides the multi-mode journey planner to help solve the last mile problem. Now this is the best part. We have mapped all the walking paths, safe and sheltered routes, right, across the entire in Singapore. So you can use it in a way to walk from point A to point B sheltered safely. We have also routing for bicycles. And a wide variety of one map APIs have been very well received by the developer communities. The local and very popular property portal SRX is an early adopter of one map. I'm very happy to note that today we are serving close to 100 million calls a month. And just a short while after we soft launched the new one map, and it's still growing. And there are some examples of my counterpart in public agencies leveraging on the new one map. Front end, the back end, the Municipal Services Office One Service app, the My Responder app by the Singapore Civil Defence Force, the Singapore Police Force Police as SG, SG Secure by MHA, which I believe most Singaporeans will have that in a handphone. And there are many more in the process of migrations to one map. Now, as a common service to serve the general public as well as the government, it is critical for one map to leverage on a reliable hosting method that can accommodate an ever-growing number of geospatial data sets and be able to serve this geospatial information to our customers satisfactorily. The new one map platform has tapped onto cloud hosting services because of its scalability, flexibility, and asset-like characteristics. The back-end infrastructure has also evolved from a single monolithic design to one which is on microservices-based architecture that the cloud caters for, which increases our service reliability. Now, with the assurance of cloud services and the comprehensiveness of the information of that new one map can offer, we have set out to encourage a wider community to adopt geospatial to help solve challenges from in the form of one map idea works. This is a 3-month-long campaign that brings developers, technologies, and community organizations together to come out with innovative, disruptive solutions to solve problems for those that don't have the means. We have received more than 60 challenge statements from organizations and around 30 solutions to help address some of these problems. On October 12th, that means next Thursday, mark it down on the calendar, 12th of October, Thursday, a finale event to celebrate the creation of all these solutions will be held at Toa Payoh HDB Hub. Admission is free. So please come and witness some of these new innovative solutions using one map and using cloud hosting services. As the Geospatial Agency in Singapore, SLA is now working on several initiatives to strengthen our local geospatial ecosystem. We will be focusing on fostering industry partnerships, catalyzing innovations, and building capacities among the people, private and public sectors. So one key initiative is the setting up of the Geospatial Center of Excellence in partnership with GovTech. And this has been supported by the Public Service Division and the Ministry of Finance. They gave us money. Now, this center will take lead in aggregating the geospatial capabilities across the public service and will provide geospatial services and consultancies to public agencies that do not have the expertise. I'll come to the end of my presentation, and you know what is geospatial now, and you know it's growing very fast, and you know its relationship with the cloud, and that's why I'm here. And of course, you know the name of the best map in Singapore. Thank you very much.
Another great example of the use of cloud technology to improve lives, improve outcomes, to bring our citizens into the future. So let's talk a little bit now about the nonprofit and NGO space. A really wonderful set of customers who set out to change the world and improve lives globally. But before we talk about the business use cases, let's talk a little bit again about technology, because we have some great examples in this area. And the next technology space I want to highlight is this notion that we call serverless. How many of you heard the term serverless? It's kind of a little bit of a confusing term. There's still servers there, right? There's still code running somewhere. But the concept of serverless is that even with cloud technology, in kind of its first generation, second generation, you either would have virtual machines where you would install and run your code, or you would use containers, which is a kind of lightweight VM technology. But there's still an element of server management where you, or some tools that you develop, I mean, you don't have to do this directly, but the point is that somebody is still managing servers. But who really wants to manage servers, right? The whole point of this is to provide powerful abstractions where management just disappears. But you still want to run code, because code is the seedbed of all these new innovations that you want to build. So again, how do we bridge that gap? And the way that we bridge that gap is with this technology we call serverless. And in particular, on our platform, the primary example of this is the Lambda service. Lambda is a service where you upload your code to the cloud, and then we take care of executing the code at the right time under the right conditions. We can scale it horizontally, we can load balance it, we can quiesce it, we can shut it down when no one's using it. And you're paying by the microsecond of code execution time and not by the second for, say, a VM that you're running. The impact of this technology has been dramatic. So we've seen everything, some amazing innovations. For example, in the US, UC Berkeley, a university you've probably heard of, they have a IT innovation lab they call the RISE lab. And a researcher there realized that he could use the Lambda environment to do parallel computing and do scientific computing by simply uploading a code snippet and then creating a storm of events. And as a result of this, he had more than 30 to 40,000 Lambdas executing in parallel every second to do a massive compute job. And minutes after it finished, it's gone, he's not paying anything. So he was able to do 2.5 teraflops of floating point performance in parallel using Lambda, and the total cost was measured in the dollars. This is unheard of for high performance computing type workloads. We have a customer in the US who deals with mortgages. It's an organization called Fannie Mae. They have to process an incoming flood of data from the mortgage industry about twice a week. They previously used a very large on-premises cluster that would crunch away for hours and hours and hours with these twice a week large data dumps. They brought that application to the cloud, refactored it to use the Lambda technology, and now they've driven the cost down to just literally tens of dollars per run, and it runs in parallel at a much faster rate. And when there's no data being ingested, they pay zero for compute because there's nothing to do. So you can think of it as an event-driven code execution model where you simply author the code, upload it, wire it up with some events that fire. The events could be something, whether you directly invoke it with an HTTP call or a update to the S3 storage service or an update to a database. You wire it up to an event of some kind, and then when the event fires, your code runs, and you can now build applications in a way where you have no interaction directly with managing servers. Super powerful, super exciting technology. It's been utilized by not-for-profits. For example, Global Giving is a not-for-profit that we work with. They provide a platform where small NPOs, small and localized not-for-profits, can reach a global audience with their message, with their needs, and achieve their fundraising goals globally. And one of the characteristics of that platform is it's a very spiky type of workload. They may have days or hours where there's very little going on, and then they have times when a lot of activity is happening. So by using Lambda, they've built a platform that enables them to handle very high load when necessary and to be super cost effective, because when there's nothing going on, they're not paying anything. So another area that we see across public sector, a growing area, is the use of artificial intelligence and machine learning. This is a very important topic. We're kind of short on time, so I'm going to go through this quickly, but we'll have some more information for you in the breakouts, and it's something you should definitely be thinking about as you plan your journey to the cloud. So let's look at machine learning and kind of this layer cake model. Let's start at the bottom. So what do you need to do machine learning? Well, first of all, you need some powerful underlying infrastructure. You need access to compute power with CPUs. Ideally, you need graphical processing GPUs, so general purpose graphical processing units. So essentially think of these as highly parallel, multi-core vector processing machines that can plow through data and analytics at an extremely high rate. Thousands of cores per chip, not just measured in the tens or hundreds as with conventional CPUs. So very, very important for machine learning and artificial intelligence. And we provide that in our base infrastructure. On top of that, you need machine learning tools and algorithms. So, and these typically, in this modern era, as the world evolves, these are almost all open source engines, which is fantastic. You have access to the source code. There's contributions from across the globe. They're getting better by the day. We've invested very heavily in open source technology we call MXNet. AWS is one of the major contributors. MIT is a major contributor. Microsoft is a major contributor. Apple is a major contributor. All these companies are coming together in these open source frameworks to build really powerful machine learning tools. One which we particularly like, as I mentioned, is MXNet. We like MXNet for two reasons. One is it scales horizontally really well in the model building and training phase when you need massive parallelism. So it is very, very scalable on the back end for the model building and training. Conversely, it's very lightweight for the inference phase. So a machine learning model is made of sort of two phases, training and inference. The inference engine is very lightweight, very fast and small. It runs fine on a mobile phone. You can do actually really good inference. Once you build the model and train it, you can download the results to a mobile phone and get really fast, real-time types of results. So MXNet is great. But there's other good systems out there. TensorFlow is widely adopted and very useful. There's a whole bunch more of these. On top of those engines, you need tools. And for our platform, we have a bunch of tools from our machine learning service to plugins for the Hadoop ecosystem, such as Spark running on our Elastic MapReduce. You need data management tools to flow the data into the systems, all the way from things like Kinesis to our batch system to our container service. And then finally, those are all the tools the developers use to build really powerful applications. But you also, sometimes, rather than writing your own machine learning tools, you want to just call an API and get a result. And so we have a set of higher level services which use machine learning under the covers, but as your developers don't need to learn these new tools and techniques, they simply call an API and get a great answer. And so, for example, we have these 3 machine learning powered services across the top. So let's just touch briefly on what these 3 are. There'll be more of these coming, a bunch more announcements coming this year at reInvent. But right now we have these 3. So Amazon Recognition, which is about image recognition, especially focused on facial recognition, but other types of element recognition within images. So you simply upload an image, and the system will tell you, it'll identify with the probability and rating of what's inside that image. Super simple, but also super powerful, and people built some amazing applications with recognition. Amazon Polly is a text-to-speech engine. So you can provide text in multiple different languages we support, and you'll get a very realistic human-sounding voice as a result of your text processing that you work with. Going the other way, essentially with Lex, it's a natural language recognition engine which enables you to take language, free-form text that users might type into a chatbot or that may be doing voice recognition, feed that through the Lex engine, and actually get back programmatic elements, tagged elements that your programmers can now work with in order to figure out what was said and then handle that in their software. So 3 really powerful services that are easy to use. Here's a great example. American Heart Association built a chatbot in just a matter of a very short amount of time for a major event that they were undertaking, and they realized that there was challenges with the workflow in terms of signing up for the event. So rather than building a conventional sort of help system where you click through and try to figure out like what the right answer to your question is, you simply type your question into a chat window, and the bot, an automatic software system, can recognize what questions you're asking using the Lex service and give you back a human-readable answer. And so these kind of conversational interfaces are really becoming popular because they interact with humans in a much more natural way than clicking through links on a web page. Let's go to kind of so this is just a really nice user experience type of use case for one of these machine learning services. Let's go to a great example in the scientific and medical space. So at Stanford University, researchers that we work with recognize that human experts, by looking at retinal scans of human eyes, are able, through their expertise, to recognize the early warning signs of the blindness that can result from diabetes. Very, very common form of blindness, one of the major causes of blindness around the globe today. Problem is, it's hard to get those retinal scans, and it's hard to get them to the experts, and there's not enough experts. They saw this as a great example for a machine learning application. So they took the human experts as creating labeled knowledge bases, built a learning engine, ingested a huge number of retinal scans, and built the machine learning model that reflected the intelligence of the human experts, so that by the time they're done with this model exercise, you can feed in a retinal scan and you can get back a very high probability answer that this person has early warning signs of this disease or not. Next thing they can do is they can take that trained model that required lots of computational power to build, and they can now download it to carryable devices. I could have a small digital camera with that inference built right into the camera, and I can be at a pharmacy and walk up to a pharmacist and for $5 get a retinal scan and know right away whether I'm likely to suffer from this disease or not. So you can take that expert knowledge, which exists only maybe in some of the more esoteric research universities in the developed nations, and you can push this out now to a very broad audience with very inexpensive technology. This is the kind of powerful promise of machine learning which can revolutionize the way that many things operate, including healthcare. If you look today across our platform, we have a broad set of customers that use our platform as their primary basis for machine learning and artificial intelligence. This is one of these, we sometimes call them NASCAR slides. You ever seen that race cars in the US where they put every single decal they can on it in the car, so the car's papered with decals, and you can hardly see the car because of all the decals? Well, we have these slides which we use, which are kind of like that. Not that easy to read, but they convey something, which is there's a lot of people doing this, and it's been a really powerful and really successful use case for cloud technology. So speaking of healthcare, precision medicine of which machine learning is only one part, is really going to revolutionize healthcare across the globe. What is precision medicine? Well, think of it this way. As we approach the human organism with modern technology, we find that more and more parts of the organism are capable of being dealt with in a computational way. It's a very weird indirect phrase, but put it this way. If I can get your genome, if I can look at the proteins, if I can look at your gut bacteria, if I can look at all these elements of your body through a computational lens, because all of those things can be modeled as numbers, and if I can then build a model and acquire to see the correlations between these things, so that every time I see this set of correlations of this set of patterns in this organism, it very, very likely this other thing will happen in the future. That kind of analysis is going to revolutionize medicine. It's happening now. The funny thing is, it doesn't even matter the causation. Like, the researcher may not know why it's the case that this set of patterns almost always results in this outcome. We don't know why, but we just know that it does. And that is enough for early intervention, for better treatment, for better outcomes for patients. And researchers will always be interested in causation as well. They can continue to do their investigations and look for those causes. But even without the causal knowledge, the correlative knowledge is extremely powerful and is revolutionizing medicine as we speak. So just for example, one quick example, American Heart Association, I mentioned earlier the use case of just a really cool bot on their website, but they've actually built a precision medicine platform where they're aggregating data, genomics, proteomics, data from clinical information, patient histories, into a very highly secure private database with the right permissions so that this patient data can be shared. And many researchers are coming to that platform to really tackle heart disease in a very fundamental way and really do some breakthroughs that we've yet to been able to achieve. And of course, all these things have to do with data analytics. Data analytics is obviously at the heart of so much of what's going on in the cloud. So let's step back from I had my three big pillars. Remember, I was going to talk about government, about nonprofit, about education. I'm going to insert something here, and I'm going to talk a little bit about how we connect all these things to the larger ecosystem. And that involves things like partners, programs, and research. So first of all, partners. AWS has this very broad ecosystem of what we call system integrator partners, the partners that know how to provide the skilled labor and the tools to help you accelerate your cloud journey. Just to name a few here, important in this community and around the region. Asia-Pac, Ufinity, Cloud Comrade, these are all really important local partners, as well as the global partners that you see here on the slide. Again, a NASCAR slide with tons of logos, but we're happy to talk to you afterwards and get into the details of which partners, which competency. And we have a website where you can actually search for partners, search for competencies, which they have shown that they have special expertise in those areas, many of whom including have a public sector competency that we put in place a year ago. So you can find partners who can help you on this cloud journey. This is on the system integrator side. On the ISV side, the software developers or the technology developers, we have a whole other range of partners. Like our sponsors, Trend Micro or Splunk, really awesome technology partners who have optimized their software to run on the cloud. Now, you can run practically every kind of software on the cloud, right? If it runs on a Linux server or a Windows server, it'll run on the cloud. So you don't need a specialized type of software necessarily, but like many things, if you take the time to optimize, you'll get much better results. So Splunk has a really awesome cloud platform, a software as a service platform, log ingestion and analytics, just to take that example. Or with Trend Micro, they've done really powerful optimizations for their endpoint protection and their other security services. For example, they've integrated with our marketplace API, so you can deploy their agents on your endpoints, and those agents will call to their SaaS platform. They'll tell you about the health of your environment, but they'll also call a billing API, and you'll be billed for all your deployments through your Amazon bill, so you don't have to pay them separately. And it'll all be based on real-time usage and not on a perhaps unused license, which we've all suffered from, right? Remember we used to buy all those licenses from vendors and never get around to deploying them and waste a ton of money. You don't need to do that in the cloud era anymore because the software vendors are moving to a pay-by-use model as well. The nice thing about the Trend model is those agents can call their platform from anywhere, so they can be called from another cloud. They can use this billing model from on-premises. They're completely generic as to where the agent runs. It's all managed through a SaaS platform running on AWS, and it's all billed through your AWS account. Let's talk about a few of our programs before we get to the final customer testimonial, which is coming up soon, very excited about. So one of the things we've done as we've gone around the globe talking to governments is governments have engaged with us and said, this is more than just a technology change. This is kind of a big change in culture and business, in education. And cloud technology is having a much broader impact, or it's part of, a broader digital revolution that government customers are very conscious of. And they've asked for help in trying to understand the impact of this technology revolution on things like workforce, on education, on policy, on acquisition, all the kind of broader topics around cloud. So we've created a program, the Amazon Web Services Institute, where we actually work with government policymakers through workshops and other kinds of engagements to broach these problems, suggest our opinions on alternatives, bring together stakeholders, and provide both policy papers, outputs of various kinds, but also a kind of informal training process and an ability to meet like people from other institutions. So actually, I think Melissa Ingber is here today. She's the head of our Cloud Institute, and she's here today in Singapore. I hope you'll get a chance to meet her. I see her in the back there. She's actually waving at me. And it's very exciting to see this project underway. Another important program, our Global Public Datasets program. So Amazon, recognizing the value of open data, which many governments have a mandate to do, under the right conditions, we'll actually host the data at our cost because we see the value to the ecosystem. So we've been able to host things like weather data sets, space observation data sets, satellite, high-resolution satellite imagery. All these things have been hosted on our cloud and have resulted in the creation of new startups, entirely new businesses. Let me give you one example. There's a startup in Germany that took the European Space Program's high-resolution satellite imagery data set that's stored on AWS, and they launched a business. And here's their business idea. They realized, they said, okay, with data analytics and machine learning, we can tell when someone starts to build something, like a building. Think of that. I mean, high-resolution imagery, if someone's building anything that's more than a couple meters in size, you can tell. So now they have a business where they'll tell you, if you're a government regulator, hey, someone started a building in this little community. Do they have a building permit? Wouldn't you like to know? So they'll give you that information. Or conversely, if you're, say, a supplier, say you supply cement or construction steel, hey, we'll inform you when a new major construction effort is underway. And you can go now find out who's doing that and try to sell them something. So again, this is a business that started when people realized the data is openly available. There's an information gap where the data is not available in a form that's useful to these particular communities, so we'll build a tool to do that. So really exciting, the kinds of things people come up with in these open data ecosystems. Cloud Innovation Centers. We've started working with customers around the globe to build these environments where startups and innovation projects can be done in a collaborative way. We contribute expertise, we contribute cloud credits, so free use of cloud. Our partners, our customers provide some capabilities, and we're able to do some very exciting and cool things together. And I hope in the future we can do something like that here in Singapore. And finally, we have a program we call Cloud Credits for Research. And this is a program in which we invest tens of millions of dollars every year, giving researchers free access to cloud to advance research capabilities all across the scientific spectrum. It's a very simple online application form. It goes into a simple workflow. Certain kinds of relatively small amounts, we have a staff that just will grant those credits based on their own analysis. If it goes over a certain threshold, we have a brief committee meeting by email. I'm on the committee to decide whether to make the grant. And we've done grant sizes all the way from very small $2,000, $3,000, $5,000 grants up to $500,000 or more in cloud credits for major research projects. And it's a very exciting way to spur innovation and to join in with the research community. Speaking of research, I'd love to call to the stage as our final customer speaker today, Mr. Swain from the Genome Institute of Singapore, to talk about some of the exciting things that they're doing with cloud and analytics and, in the future, serverless computing. Welcome. There you go.
Thank you, Mark, for a great introduction to some of the technologies as well as the motivations that are driving a lot of the work that we're doing at the Genome Institute of Singapore with Amazon Web Services. And thank you all for coming and staying through this slightly extended keynote session here this morning. So I'm going to go into a little bit more detail about what the motivations are at the Genome Institute of Singapore for us to need Amazon Web Services and how that's helping us to transform how we're doing research, which I think is going to take us out of our comfort zone currently and move us into not just some of the healthcare applications that Mark mentioned, but into some things that are going to have impact on the broader society and the city. Okay, so again, my name is Swain. I represent the Genome Institute of Singapore today, which is one of the research institutes at the Agency for Science, Technology, and Research. A*STAR is part of the Ministry of Trade and Industry. We're located in a building in the Biopolis complex, which is really an amazing community of thousands of researchers that's near the Buona Vista MRT station. If you've never been there, I encourage you to come by and say hello sometime. So at GIS, we are the Genome Institute of Singapore. We are a center for genomic discovery, and this is a little bit different audience than I'm usually addressing in terms of the breadth of expertise. So just to make sure everybody's on the same page, we studied genomics. So let's just make sure everybody knows what genomics is. So me, you, the plants outside, animals you can think of, right? We're all made of cells. And inside every cell, there's a nucleus. Inside the nucleus, there's chromosomes, and the chromosomes are made of DNA, right? So hopefully most of you remember this from some time, either somewhere between either grade school and university education, right? So there's a lot of DNA that's packed into these chromosomes, and of course DNA is what gets inherited from generation to generation. So that's what we refer to as genetics. And then when we talk about all the DNA inside of an organism, all the DNA inside of a cell, okay, that sum total of DNA, that's what we call the genome. Okay, so there's genetics, and then the entire set of DNA is the genome. And genomics is the study of genomes. So you guys might remember also that DNA is the blueprint for life, right? You might have heard this phrase. It's what makes us humans. And the trees have different DNA, and that's what makes them trees. Fish have different DNA, and that makes them fish, right? But not only on these large differences, but the differences between you and me, or between the people you're sitting next to, even though you're all humans, there are still sequence differences between you, and that differentiates all the individuals in this room as well. And so that's a really important thing, because we can be very specific at identifying individuals, whether they're human or not human as well. And so this is one application for genomics, is for us to manage and track outbreaks. So because of this, we can know exactly whether different individuals got infected by the same bacteria or the same virus. We can tell where that virus came from, and that helps us to track and manage these things if we can see what the pathway of infection is. Okay, and so just two prominent examples of many that GIS has worked on over the past 15 years. There was a SARS outbreak that happened and hit Singapore in 2003, and the Genome Institute of Singapore also helped apply some genomics to understand what was going on with the infecting organism there, which was a virus. And then more recently, in work that I was involved in 2015, there was an outbreak of Group B streptococcus that was coming from the yusung fish, the raw fish that was being sold in some of the hawker centers here. And again, just to dive a little deeper into why genomics was important for that, right? So again, we can use genomics, we can use the DNA sequence to tell the difference between different individuals, including different types of Group B streptococcus. And it became extremely clear, and not just extremely clear, it was patently obvious that the Group B streptococcus that was infecting the patients was the exact same strain as was found on the fish at the same time, at the same place. Okay, so that really helped us to establish that connection in a very strong way using genomics, that this was the source of the infection, and also gives us the tools to track that outbreak, manage it, and also gives us tools to make sure that we can monitor and make sure that doesn't come back again. Okay? So this is one application for looking at outbreaks, which relies on genomics. Another one is another important thing that was touched on already by Mark, is that your genetics, your DNA affects your health. So I'm showing you a picture here of Angelina Jolie. Many of you might know that she, several years ago, underwent a double mastectomy to reduce her risk of getting breast cancer. Okay, and why is that? Now, the reason she did that surgery without having cancer, okay, so she underwent surgery without having cancer because if you look at the graph on the left there, if you look at the graph on the left there, the average person has a risk of getting breast cancer of about 2% by age 50. But Angelina Jolie did a DNA test. She knew about some sequence differences in her DNA that meant that her risk of getting breast cancer was up to 50%, okay, a 1 in 2 chance. And that's the reason that she went ahead and did the double mastectomy, because of course breast cancer in itself can lead to death as well, okay? So I want to just go into a little bit more detail as to what that test actually was and what the process is to get to that test, so we can understand where it is that genomics comes in and where it is that Amazon Web Services can really have a big role to play in this. So Angelina Jolie, the test that she had taken was for these 2 genes called BRCA1 and BRCA2. It doesn't matter what they are, but they're just 2 of many, many genes that are present in all humans. Doing that test, taking that test kind of looks like this, right? So I'm showing you a bunch of G's, A's, T's, and C's, and that's how we represent DNA sequence. And just for the next couple of moments, you'll hear me say the word base pair, or BP. So base pair is like the first A there would be a single base pair. The next G would be another base pair, okay? So I'm showing you about 1,000 some base pairs here. And really that test is sort of like this. Hey, we see one of these is different, and we know that that difference changes Angelina Jolie's risk for having cancer. Okay, and so this makes it really easy when I color it in a different font and make it bigger, right? But that's not how DNA is. And in reality, I'm showing you 1,000 here, but the entire genome that's present in Angelina Jolie and that is present in all of us, the entire genome is 3 billion base pairs, okay? So sure, we've heard a lot about scale and computing, but there's a little bit of an interface with actually getting DNA from a cell into a computer so we can actually analyze it. And 3 billion is still kind of difficult for us right now. And it's too expensive to do this in general. So what we have to do is essentially what I've done up here. We have to sort of narrow this down. We have to figure out where are these BRCA1 and BRCA2 genes, and what are the sequence differences within there so we can focus in and look specifically at those differences out of this 3 billion base pairs. So to figure out which places to look takes an awful long process of research. It took us 17 years, it took the research community 17 years to go from we knew that there were risk factors for breast cancer to narrow that 3 billion down to 10 million took 17 years of work. Okay, 10 million is still too big. It took another 4 years after that to whittle that 10 million down to 5,000. And once you're at 5,000, now this is about the size that we can kind of, we can do this relatively routinely in the lab. And this is actually the kind of test that Angelina Jolie took, where they're looking specifically at a very small region representing BRCA1 and BRCA2, okay? And then from there we can take those, take that information and then make a prediction about risk. I should say that this 21-year process was done mostly in the pre-genomic era. This is before genomics, okay? And this is certainly one of the goals of genomics, is that can we accelerate this process? And fundamentally, it's a 21-year process before genomics, so how do we accelerate that? And as mentioned already, genomics, of course, is very data-driven. It can be computational. Computations are a huge part of what we do at the Genome Institute of Singapore. So when this really boils down to how do we actually solve this problem, I think it's a pretty standard setup that many of you will be familiar with. If we want to do a data-driven data-driven approach to this, we first of all have to have data. And I said that there's some special things about the fact that the data that we want is actually in your body, in your cells, in your blood, as opposed to sitting on a computer on a digital device somewhere already. Okay, so there's a data acquisition problem, and then there's a second problem, which is, of course, what we've been talking about all day today, which is how to do the analytics in a good way, okay? So I'm going to talk about these two things, data, then analytics. And so the data part, to be honest, it's getting solved, and it's getting solved in a quite reasonable way. It's getting solved in what I would say is the usual way that many of you guys would be familiar with. So you probably have all heard of Moore's Law. It's an exponential rate of progress, which has truly transformed our relationship with computing, right? So over 40 years of Moore's Law, it's turned computers that were the size of this room to each of us having one of these in our pocket, right? So this is what Moore's law can do, and it's truly transformative, truly revolutionary. And that's sort of the normal way that we think about, sort of really revolutionizing progress. Genomics, in terms of getting that DNA out of your cells and then turning it into something that we can process on a computer, we were actually following Moore's law for many years, which is great, right? So Moore's law, that's going to get us there if we just keep pushing along that rate of progress. But you can see about 10 years ago, we started going even faster than Moore's law in terms of data acquisition. Okay, so this is why I'm saying that data is getting solved in the usual way, or we're just not worried about data acquisition at this point. Our ability to acquire data is going so fast right now. It's going so fast that it's actually unsolving the other problem that we have, which is analytics. Okay, so analytics is getting unsolved in a way that we've never seen before. Again, when you're dealing with a fully digital environment, Moore's law is going to help you in every single way. When we're acquiring data faster than Moore's law, now Moore's law is making us fall behind in our analytics capability. Does that make sense? And so, this is a log scale on the y-axis over here. And so as this curve goes forward, we're exponentially falling behind. We can see this in our projections. We are exponentially falling behind in our ability to not only store, but also to analyze data. Okay, and so this idea that this is getting wider and wider. I call this the Hypermore gap. Okay, and bridging this gap, to be honest, there's a very, very simple solution to bridging the Hypermore gap. Okay, and that is we need an exponentially increasing budget to buy computers. I've made this proposal several times. It hasn't gotten approved yet. In the meantime, however, fortunately, we have Amazon. Okay, so we're a single institute, and we actually do manage our own compute environment. But the ability for us to scale as a single institution, really, it just has no comparison to what we can access when we move over to Amazon Web Services and blow that out to a global scale. From the point of view of an individual institute, it's essentially infinite, the amount of resources we're now enabled to have access to. Okay, and so this is one of the strongest reasons, or this is the strongest reason that we need Amazon. It's not just that this is nice and they've got all these services and there's security. No. Just the trends in the industry, we absolutely need somebody like Amazon to solve these problems for us. And so what it is, I talked to you about data, right? That's getting solved in the usual way, and it's getting solved in an even more, like what I call hyper-more fashion. But then the analytics, really for us, boils down to two problems, right? Because it's going faster than Moore's law, this turns into a distinct infrastructure problem that we're just not able to solve. That's not our expertise. And that's where Amazon comes in. And then that now allows us to focus, which you heard before, that allows us to focus on the things that we know how to do, which is the analytics, which is the genomics, and relating that to biology. Okay, so just as a very concrete example of what the scale of Amazon really gives us. We had a project not long ago where one of my colleagues at GIS was involved in a collaboration where they're sequencing some cancer samples. Okay, so this project is called OncoSG. It's in a collaboration, so science is a very global endeavor. So once we had the data, we had to share it with the collaborators so we could all work together to do the analysis. So the problem is we needed to share 60 terabytes of data with the US and try to do that quickly, and there are multiple people in the US that they needed to share this with. Okay, before we started talking to Amazon, we're trying to solve this problem, and the best solution was to go out and buy a stack of hard drives, copy all the data over, and then physically ship them over to the US, to each of the collaborators, okay? I should say that this was 2015, 2016, something like this. And if you think about this, the proposal is to use a technology that's 60 years old, which is jet airplanes, okay, to actually send this data over in 2016 in order to solve this problem. As soon as we started talking to Amazon, 2 weeks, $5,000, for less than the cost it would have taken to get the data to 2 collaborators, it was all done. And really, this is just leveraging on Amazon's scale and on their ability to execute on technology, or their ability to keep up with technology more so than an individual institute can do on its own. Okay, so Mark also talked about one of these new technologies that we're extremely excited about. And just to preface that, I want to talk about, like, the example that I just gave you really is more about, we still have to think about what the infrastructure is. We still have to kind of deal with the hard drives, or like, how are we going to actually transfer the data, right? But if the infrastructure problem was actually solved completely, we wouldn't even think about it. And this is what Mark was talking about in terms of the Lambda service, right? So we could actually sort of let that fade into the background. Not that it's not there, right? But we just don't have to think physically about it or really consider that so much anymore. And we can, again, now focus more on the analytics, which is what we're better trained to do. And to give you a visual analogy of what that is, it's sort of like this, right? So this is a famous series of images of a horse that's running. It's just a bunch of snapshots. And from this, you can kind of infer how it is that a horse is running. And this actually was a key thing at the time. This is the first time people actually realized really how a horse's legs move when it runs. But what I refer to as infrastructures, you kind of have to say, okay, well, how are the pictures arranged? What's the timestamp on all these guys? How are they all related to each other? Okay, that's like thinking about infrastructure, and if you do that for a little bit, you can figure it out. Alternatively, if I just get rid of the infrastructure for you, it looks like this, right? It becomes patently obvious what's going on. We may be able to accelerate insight. We can just do what we do best if we don't have to think about infrastructure. So this is really the vision that Amazon has had, and we're extremely excited about this. We're just starting some projects to move on to Lambda now, and it really is no servers to manage, continuous scaling. We already, Mark touched on cost just a little bit. So just by the cost metric, right? For us to buy computers, maintain them, we got to plug them in and run them. So that costs power. So we have to pay for that. That power all turns to heat. So then we got to pay for more power to cool the heat, right? So if you just take all these costs to the extent that we can, kind of get a best number for how much it costs to do analysis for us. Per unit cost, we're doing something like 30, 40 genomes of analysis. And moving to Lambda gives us 1,000-fold savings because we don't have to worry about infrastructure costs. We don't have to worry about power bills and stuff. We just pay for usage. We just pay for compute. Okay, and I'm not even talking about the time savings that we get based on the parallelization that comes out of this. Okay, so I want to leave you with just a vision of where we think we're going with this, really, and it's a vision that's enabled, one, by the hypermore progress of data acquisition, as well as, two, Amazon's ability to let us not just sort of struggle, without Amazon, we're sort of struggling to keep up with the data. With Amazon, we can envision not just shifting our line down to that hypermore progress line, but actually getting ahead of that because their scale is so big. So what we do today at the Genome Institute of Singapore is our current focus is really when you come to the hospital, we know you're sick, we can help you with precision medicine, with understanding your genome to help you do diagnosis as well as picking the right treatment. And if you think about it, the concept here is because it's the same concept as having a physical hospital. You have a hospital there because not everybody is sick. You have a hospital there because when you are sick, now we know we need to devote a lot of resources. It's very resource intensive to figure out what's going on with you and to take care of you. And you want to focus that on the people that are actually sick. And that's what we do with genomics as well, because things are still a bit expensive. And so we are key partners for Singapore, as well as many other countries, are launching precision healthcare initiatives, as touched on by Mark already. And I think Singapore is really a big leader in this space, and GIS is one of the key, is the key genomics partner, as well as computational partner for Singapore's precision health pushes. But what does a hypermore rate of progress look like, especially enabled by Amazon, right? So computers the size of this room versus in your pocket. We won't have to worry about the costs. We won't have to worry about the sort of intensity of resources on the genomics side. Certainly hospitals, we're not going to build them everywhere, right? But for genomics, it's going to be pervasive. It's going to be ubiquitous. It's going to be cheap. And what that means is we can push our mandate out, and we're thinking definitely along these lines that enabled by Amazon, we can go out and, just like with Angelina Jolie, before she gets sick, we can figure out what's going to happen and then help people make these decisions to manage their healthcare, right? We can be preemptive about this, but to be preemptive, you have to scale this up to the entire population. Okay, and that's what the data scaling is doing for us, and that's what Amazon scaling on the infrastructure side are helping us to do as well. So this was mentioned already. Of course, Singapore has a smart nation vision, and GIS's contribution to this, what we see our role for this, if you look at some of the little key things as to where smart nation kind of can change your life, we think there's lots of genomics applications. We will be embedded in genomics. It will be ubiquitous. And there's many places, not just in healthcare. You can think about crime investigations. You can think about food security and food safety. You can think about import and export, the health of your environment. These are all things that, when genomics is ubiquitous, will be extremely, something that is going to really change our lives in the future. Okay, so that's all I have for you. Just a couple of thanks. Really, the Amazon Web Services people have been outstanding partners for us, and we really would like to thank them for all that they've done for us at GIS. A couple of key names at GIS that are leading some of the Amazon Web Services projects, related projects, as well as some of the logos for the initiatives, both within GIS as well as nationally for precision medicine as well as infectious disease outbreak tracking. Thank you very much. Hey.
Thank you so much, Professor Swain. Really excellent presentation, driving home some of the key messages for the day. So let's briefly cover education, and then we'll get you out of here a little late, but we'll adjust the schedule appropriately. Education is a great market for cloud services. With the agility, benefits, and cost savings that we've talked about, and the increased security and capability and privacy-enhancing capabilities of cloud, the innovation that results, you can improve student experiences and dramatically increase student outcomes. You can improve student outcomes. So this is really the message that we bring to the education market. And through this process, we'll create the next generation of superheroes with their cloud powers that can do these great things we've been talking about. You've already heard earlier from Peter about the AWS Educate program. This is an online portal where you go and sign up, and I would encourage you to try it. This will enable you to get access to a lot of online learning materials, to create tracks and target at certain types of skill sets, which then lead to certification and career paths and career tracks that are available. It can be used by educators to create online courses, to share curricula and content, and basically to raise the boats on this rising tide of cloud and education. Throughout Asia Pacific, we're partnering with critical and important universities, including here in Singapore, the Singapore Management University, the Singapore Institute of Technology, Nanyang Polytechnic, and many other institutes. So to conclude our presentation today, we've talked about how cloud is empowering a digital transformation across the entire public sector, government, not-for-profit, and education. We've talked about the superpowers, how this change in technology enables dramatic improvements in cost, agility, improved security, and improved ability to deliver mission in a very, very rapid and efficient way. We talked about how really superpowers are all about doing things. It's about doing and not just talking. For so long, we've sometimes got stymied, as Mark said at the beginning, with overanalyzing problems. Why? Because it's so expensive to make mistakes. In a traditional IT environment, the risk of error is just incredibly high. You acquire a bunch of equipment, you acquire a bunch of software, you try something and fails, it's a disaster. We've got to get out of that model and get into this experimental model where IT becomes more like a scientific project, where experimentation is at its heart. So with that in mind, I want to encourage you to enjoy the rest of the conference today, to engage with the community here, and to go build new technologies, new services, satisfy the mission, and meet those mission needs better than you've ever been able to do them before. And we're excited to have you here today, and thank you so much for coming and sharing in the keynote.
Thank you so much. Can we have one more round of applause for all of our great speakers today? All right, we ran a little bit long, so the tracks will actually be pushed back 15 minutes. So you have a little break to go visit our sponsors. Please do that and have a tea break. And then we'll start up at 11:15. So just like we do inside Amazon, work hard, have fun, and make history. Thanks, guys.